A very good afternoon to Madam Eliana Binti Ruslan. I'm Naguli Suresh from 2BEE S1/1 with my group members Yasagi Saudaraja, Anik Aklan and Irfan Najan. Today we're going to present the communication principle project. Firstly, I'm going to present about introduction part of our topic, amplitude modulation. Amplitude modulation is the process in which amplitude of the carrier wave will change in accordance with the modulating signal wave. AM modulators are non-linear devices with two inputs and one output. One input is a single high-frequency carrier signal of constant amplitude, and the second input is comprised of relatively low-frequency information signal that may be a single frequency or a complex waveform made up of the many frequencies. The modulated output waveform from an AM modulator is often called an AM envelope. Next, figure 1 shows the amplitude modulation AM waveform. This modulated signal and then carrier waveform and amplitude modulated signal. Then the waveform of AM consists of two signals, modulated that is baseband and low frequency signal, and carrier that is high frequency signal. These two signals are mixed together in modulator to obtain amplitude modulated signal. There are four types of the amplitude modulation. Firstly, double sideband with carrier. Call it as AM. This is the most widely used type of AM modulation. In fact, all radio channels in the AM band use this type of modulation. And the second one is double sideband suppressed carrier, DSPSC. This is the same as the AM modulation above but without the carrier. And the third one is single sideband is called SSP. In this modulation, only half of the signal of the DSPSC is used. And the last one is the vestigial sideband. It's called VSP. This is a modification of the SSP to ease the generation and reception of the signal. That's all from me. Thank you, madam.
Assalamualaikum warahmatullahi wabarakatuh. So today I will explain about methodology. So amplitude modulation AM operation and equation. The modulation index M decides the type of modulation in AM. The modulation index M is defined as the ratio of amplitude of modulating signal to amplitude of carrier signal. When the value of M equal 1, it is perfect modulation. When the value of M is smaller than 1, it is under modulation. When the value of M greater than 1, it is over modulation. So for the frequency spectrum, the frequency spectrum of an AM wave is the graph of amplitude on y-axis and frequency on x-axis. The frequency spectrum gives frequency component information present is AM wave and their amplitudes. It consists of two sideband and carrier. One sideband is upper sideband USB and under is lower sideband LSB. So this is the formula for to find AM, and this formula to find bandwidth. So we to find the bandwidth is BW equal USB minus LSB, or FC plus FM minus FC minus FM. So this is frequency spectrum of AM. Okay, next, time domain representation of AM wave. So Modulating signal of AM wave is represented as EM equal EM sin omega M T. So where EM peak amplitude of modulating signal omega M equal to pi FM. So for the carrier signal of AM wave is represented as EC. So where EC peak amplitude of carrier signal formula is omega C equal to 2 pi FC. So AM wave is expression as so this is the formula to find AM. So it is the instantaneous value of a value is given by A equal EC plus EM. So for the equation for formula. So next, uh, implementation in MATLAB. So in MATLAB, the coding for message signal, carrier signal, and modulated signal waveform are writing based on the equation above by using MATLAB. So message signal is the signal which contains a message to be transmitted, while carrier signal is a waveform. Uh, then is modulator modified when its information bearing signal for the purpose of conveying information. In order to implement AM in MATLAB, we also need to design the equation of AM practically using simulate library block. So that's all for me. Thank you, madam.
Good morning, madam. I'm Yashiki. I'm going to explain about result part. So this is the MATLAB coding. So given A1 equals to 4, the A1 will be the amplitude for the carrier. The frequency carrier will be 50 Hertz. Then the amplitude for the message signal will be 2. And the message frequency will be 5 Hertz. So the MATLAB coding, they will have 4 parts. Part 1 will define the types of waveform, amplitude, frequency, and phase for each signals. So this is the define for the amplitude for the modulating signals. This one the amplitude, frequency, and also the carrier for carrier signals, and the sample rate. Okay. For part 2, we will generate the information signals, carrier signals, and full AM amplitude modulation signals. So this is the equation for to generate the message signals, carrier signals, and also the amplitude modulations we carry. That means the message signal will be modulated with the carrier signal. So that's why it's form of full AM modulations. Okay, then for part 3, we will define the N as the input data to find or define the number of the points in FF state for Fourier theorem. Okay, and then the AM signals is in continuous with signals to perform the Fourier theorem. Okay, so this is the equations. The operations for the number of for Fourier theorem. Okay, so part 4 will be the comments code for each output. There will be 4 outputs. Output 1 will show the plot the message signals. We will plot for the message signals. That means the output for the waveform for message signal. This one is the carrier signals, the output. Then this one the amplitude modulations with the carrier signal. That means the amplitude modulation waveform. And this one will be the spectral analysis. So spectral analysis is the single-sided PST. Single-sided PST. That means it's a spectral analysis means single-sided PST. And then this is the outputs that we get. There will be 4 outputs for that one. So I'm going to show in MATLAB. Okay, this is the part 1, the coding. Just now I mentioned in the slide. Okay, then we run. And then we go for the coding 2. we run the generic part, we run. And then coding tree, it's about the number of the F50 points we're going to run. And this one will be the outputs. Okay. So this is the waveform that we get. This one message signal with the frequency of 6 Hz. This one the carrier signals with frequency 60 Hz. This one the amplitude modulations with carrier. This one when the amplitude modulation for the message signal we change to the convert to 3 volt. So this is the amplitude. I should try again with another values. So the amplitude signals the carrier amplitude for the carrier signals I convert to 5. So this is the waveform with 6 Hz and also 60 Hz. Okay. For examples, I try with another values. This one when the amplitude will be 3, frequency 6, this one 5 and 60 for the carrier signals. I change to another value to show that it's different. This one be 5, this one 4, 50. Okay, when I run, then okay, coding 2 I run, coding 3, and coding 4 when I run. So we can see here the frequency is changing. Just now will be 6 Hz, right? For the we set 6 Hz for the message signal. Now it's become 5 Hz. Carrier signal is 50 Hz. This one's the amplitude will be 2 volts, and this one will be the amplitude will be the 4 volts. Okay. So this is the amplitude modulations we can use. Okay. Now we're going to see for the we further with the we continue with the slide. Okay, we continue with the slide. Okay, so this is the stimulation. So we got plot. We got construct. This is the block diagram, the amplitude modulations in the Stimulink. So I will show the Stimulink. Okay, so this is the Stimulink. First, we use the signal generator as the carrier signal here. So message signal, we will connect it with a constant 1. And then this is a scope to show the output of the waveform for the message signal. This one for the carrier signals output. Then when this combine is with product using the product form, then it's become the modulated signal. So this is the scope. We use the scope to show the modulated AM modulation signals. Okay. So when I run, so the values I said is the amplitude 560 Hz for the carrier signals. As we in the examples, second example that I give just now, 3 and 6 Hz. So when I run, so this is the carrier signals. It shows that it's a 5V, the amplitude. This one will be the 3. Just now for the what do you call the message signal. This is the scope. Okay, this is the modulating signal. Okay, so that's all. Okay, that's all from me. Thank you.
Hi, Assalamualaikum. Um, my name is Muhammad Ani Adlan. So today I will present about discussion and conclusion for this assignment. So discussion of this assignment is for the first part of this project. The desired equation and operations have been determined for amplitude modulation AM. Then, coding for amplitude modulation is written and we observe the output waveform for message signal, carrier signal, modulated signal with carrier and spectral analysis single site PSD when run the coding. Then, to further determine the characteristic of amplitude modulation signals, we construct the stimulating block diagram in MATLAB. We are compare the output waveform that we obtain from stimulating block diagram with output when run coding in MATLAB. Message signal graph and carrier signal graph has frequency of 5 Hz and 15 Hz. However, carrier signal graph normally bigger than message signal graph. Based on the graph obtained, it can be stated that message signal graph has an amplitude of 2 while the carrier signal has the amplitude of 4. Amplitude modulation is the process of changing the amplitude of a relatively high frequency carrier signal in proportion with the instantaneous value of the modulating signal. Amplitude modulation with carrier graph is the change according to message signals with frequency wave. Amplitude of message signal with frequency adds up with amplitude of carrier signal with frequency will be the amplitude of the modulation with carrier signal. So next slide is the conclusion of this assignment. So we see that carrier signal have larger frequency than message signal because in the frequency range of the modulating signals there is usually not enough space to accommodate all the signals. With the cooperation of team members, we are able to complete this assignment successfully by achieve the main aim of this assignment. So thank you from me and thank you for Madam Eliana. Okay, thank you all.